Okay, so just a little something before I have to get going in a little bit. But one of the things I'd been talking about was figuring out how to get graphics out of the in an NES style to be available for our GPU that I want to implement in the FPGA. So one of the things I thought would be helpful is to start by starting with the actual graphics formats that were used in the NES to see if we can adopt them in some way that will, be pretty easy for us to adapt any existing NES graphics that we really like. So right now we still see that little guy bouncing around, and that's all from kind of very carefully hand created. Let me show you in here. Very carefully graphics compositor, sprite compositor. So the character from there we go. The character that you see there is basically, I went through it, I pulled out a sprite from Pac-Man and myself described and defined all of the pixels and the color selection that we should use for each pixel. Not really the way I'd want to handle this in the future. So you can see here I defined a color palette. Right, there were 4 colors in that image. One of them is just black, which we treat as transparent, and then red, white, and a kind of slightly lighter blue. So the thing is that the way I did that was I just defined a bunch of parameter data, right? This is not the way that you want to do this, and definitely don't want to do this going forward. But this format is just something I hand built basically, right? So every pixel, so this image is actually 16 by 16 pixels right now, and every pixel has one of 4 colors, or actually one of more than 4 colors, but that's besides the point. So every pixel here is defined this way, and you can actually, does this work? Yeah, so you can see the shape. If I select all the black pixels, you can see the shape of the Pac-Man ghost there, stretched out horizontally because each one of these is more characters, but you get a sense of what I'm talking about. And if I do this one, then you'll see that Pac-Man ghost again, his figure, the way that it's set up. And over here you'll see the eyes are color number 3. So that was okay, but it took a long time to figure this out, and I am tempted to say that we could always just use a sprite format, which is either similar or identical to how the NES does it. So this is the Super Mario Brothers ROM opened up with a character palette editor that lets us actually look at the images, the sprite data, and the tile data. You can see here all the letters and numbers, also the score numbers that might show up when you jump on an enemy. Um, you can see here pieces of Princess, parts of the flag. Mario's up here as well. There's parts of Mario, and all these things can get combined in different um, directions and with other sprites to make all the particular images that you may know and be very familiar with. But I just wanted to start with something simple that I could look at and understand. So this here you can see is the top half of the mushroom, um, both the one-up mushroom and the super mushroom. And it's pretty simple. It only uses 3 colors. There's a black color, there's the body of the mushroom, and then there are the spots. I already changed the palette down here so that it's just easier to kind of see and understand that this is the top of the mushroom. The bottom of the mushroom is somewhere. I don't know where. I haven't found it yet. There's a spiny, by the way, the shell of the spiny at the top and the bottom part of the spiny over here. But anyway, back to the mushroom. So one thing I had to understand was how this data is actually encoded in the ROM. So over here I have a hex editor open, and I got the offset from this part up here, and came down here to the data, and I found the row that has our mushroom data. Where'd it go? So the mushroom is at 08 hex 8770. 8770 right up here. And what I expected, since every one of these pixels that you see, and I can zoom in this again. So this is one sprite, is 8 pixels by 8 pixels on the NES. And I thought that the way the data would be defined, since every pixel can be one of 4 colors, that we'd have 2 bits for the first pixel, 2 bits for the second, 2 bits for the third, and so on and so forth, and go all the way through that way to define the pixel image. That is not the case. Actually, I found this article over here. One of the things it mentions is that characters are encoded with 2 bits per pixel but not stored adjacently. So first it stores just the low bits of the image and then the high bits of the image in sequence. And so this mushroom was actually a really great way to learn how this works. So I'll keep this over here. I have my hex editor over here. This editor is great because it also shows me the binary, and since the NES was a very memory constrained system, right, like everything is defined using as few bits as possible, and that's pretty nifty and helpful for us right now. So over here is our mushroom, and in this row, these 16 bytes define all of the data for the sprite. The first 8 define the low bits for the whole image, and the next 8 define the high bits for the whole image. So let's start by looking at, we can look at each row one by one. So every byte defines one row of the image. So this first byte 03, you can see here is 6 zeros and then 2 ones. And if I look at our sprite image, it's 1, 2, 3, 4, 5, 6 black pixels, and then 1, 1, 2 yellow pixels. Come to the next row, and it becomes 3 ones at the end, and 1, 2, 3 yellow at the end. And so on for 4, 1, 2, 3, 4. Then here, the 5, 1, 2, 3, 4, 5. Then here, 6. Then 7. So you'll see, the reason that this works, or was easy to understand, you can say, wait, hang a second, these are a different color, and they are, but this yellow color here is defined as color 1, 1, and this red color here is defined as color 0, 1. So the low bit is still a 1 on the red ones, but you'll see that the high bit will be a 0, whereas on the yellow color, the high bit will be a 1. So anyway, so we'll go through the whole image, right? The last row is all 1s, and the last row of the sprite is all yellow and red pixels. So everything matches up very nicely. The next we're going to look at are the high bits. So when we look at the high bits, again, the top row, yellow, is 1, 1. So we see 1, 1 for the last 2 pixels. And then again, 3. Then again, 4. Then 5 and 6. Now it gets a little different. So the last 3 rows have those red pixels. And that's why you'll see now the color is 0 for black, then a 1 for the yellow, a 1 for a yellow, then a 0, 0, 0 for the red, then a 1, 1 again for the yellow. And that's because red is defined as color 0, 1 in this palette, and the yellow is defined as color 1, 1, and the black is just 0, 0. So then we'll come here and we see 1 black pixel, the first 0, then 1 yellow for a 1, then a whole 5 red, and then the last one again is our yellow. And in the final row, we see zeros this time because we still have those 5 red pixels in the middle, but they are, bookended by a double 1 on the left for our 2 yellow pixels, and a 1 at the end for our tailing red pixel. So with all of that, what I want to see is, I wonder if I can take this sprite format, and I don't know, I think it's kind of silly design. Maybe it makes sense because it lets you pull in the entire sprite data as one kind of 8 byte kind of load at a time. I mean, honestly, if I adopt this as a format, it'd just be for the sake of convenience that I can then pull out a whole bunch of sprite data from NES ROMs and be able to use it, pretty easily. There also are a lot of tools that make it easy to export NES sprite data. So, if someone else wanted to work with the format, they can use a whole existing tool chain that's meant to make it easy to make sprites and then to get the byte data. So, that could be programmed into a program on an embedded device like the one that I'm trying to build here. So there are a few reasons why that might be a good idea. I don't know yet. I guess we'll have to wait and see. Um, the next step for me, knowing now that I can accurately pull out the sprite data from an NES ROM, at least from Super Mario Brothers, is to see if I can actually copy and paste that into my design for the hardware over here and kind of rework the data so that it will so that it'll work. And so I can actually get mushrooms bouncing around on the screen or Mario bouncing around on the screen rather than just our Pac-Man ghost who took me a long time to encode. If I can just basically copy and paste this information and then get a different sprite to show up, I think it's a big win. And then it's really just a matter of figuring out how to make the FPGA read the data in this format instead of the format that it's using currently. And that may not be as hard as I think. So we're going to have to wait and see. But that's really all that I have time for right now. Hopefully tomorrow I'll be able to plug in to spend more time here in Vivado and actually, get something working.